We're going to start to learn about alkenes and alkynes. But before that, we're going to have a short review of naming alkanes. If you feel comfortable with that already, you can skip ahead about 3 minutes. Let's look at the IUPAC naming of alkanes. First, I want to remind you that the names will be all one word. Because I'm writing them backwards, sometimes there will be spaces between the words. There is no actual space. I'm just not perfect at drawing them. Just know that there are not supposed to be spaces between the words and letters. The first step in all of our naming processes will be to find the functional group, which will identify the class of compound. In this case, our class of compound is alkane. There is no functional group, but since it's an alkane, the ending will be -ane. The next step is finding the main chain. You want to find the main chain that includes any important functional groups. We have no functional groups, so we won't be including them. We want to find the longest continuous carbon chain in this case. I like to highlight the main chain so that I can easily see any substituents that are attached to that main chain. If the main chain is cyclical, we'll write the prefix cyclo just in front of the main chain's name. Next, we'll write down all of the substituents and identify them by name. Then we will put those in alphabetical order in front of the main chain's name. So what happens if I have more than one of the same group? In this case, if I have 2 of them, I would put di. If I have 3, I'd put tri. If I had 4, I'd put tetra. We can continue following that pattern, going up to 10 if need be, using the covalent naming system we've learned before. Now that we've placed all of our substituents in the name, we must number them. We need to tell the location of each of these substituents. The best way to do that is to number the carbon chain first in the forward direction, and then in the reverse direction. Notice that it's easiest to use 2 different colored pens to indicate which direction you're counting. Now figure out which number each substituent is attached to in the forward direction and total up that number. Then do the same for the reverse direction, counting which carbon each one is attached to and total that up. We can't use both directions in our name. We have to choose one. The way that we choose which one is the best direction to choose is by finding the lowest total number for the substituents. This is only true for alkanes. We will not see that for the rest of the functional groups. Now that we've determined which direction we're going to number the alkane in, we're going to find which position each alkane is on and write a number for every single substituent. Each substituent needs to have a number. If there are 2 or 3 of the same things, we'll put a comma between the numbers. Otherwise, between the number and the letter, there must be a dash. Those are the rules for naming alkanes. Now let's look at how it changes when we go to alkenes and alkynes. When we look at the naming of the alkenes and alkynes, we will see that in many ways it is very similar to the naming of alkanes. But there are a few major differences. The first place that we will see a significant difference is in the suffix. For the alkanes, the ending was always -ane. Now we have different functional groups. So if we have a double bond, it's called an alkene, and the ending will be -ene for alkene. If we have a triple bond present, the ending will become -yne for the alkyne. The next major difference is in finding the main chain. In this case, it's not just the longest continuous carbon chain, but it has to be the longest continuous carbon chain that goes through the double bond. The next big change is going to be an addition of a step between 2 and 3. We're going to add one more step in where we find out that the double bond or triple bond takes over priority and decides which direction we will number the whole compound. We must give the double bond or triple bond the lowest number possible. Therefore, we do not have to find a total. The next step follows the normal pattern of writing the substituent names in front of the new number that you placed for the alkene or alkyne, and then we add in the substituent names in alphabetical order, and we use di, tri, and tetra to indicate multiples. Notice that we also use those di, tri, and tetra in front of the alkene or the alkyne if there is more than one of them. So the answer would have the number of the chain, then di, tri, tetra, and then "-ine" or "-ine" when we do those names. And of course we would have to number each of those double bonds or triple bonds. Everything gets a number. And the last major change will be in the way that we number the substituents. We will no longer need to count forward and backwards because we've already done that before. In step 3, we decided which direction to count. Once the direction has been decided by the alkene or alkyne, then we can give all of the substituents their numbers. Be sure to give each substituent its number, putting commas between numbers if there are multiples of the same substituent, and recall that you must put a hyphen between any number and letter. And that is the naming of alkenes and alkynes. Now let's summarize those changes. The first step in naming all compounds will be to identify what type of compound it is. When we spot the double bond, we know that it will be an alkene, so we'll use the ending "-ine." If we see a triple bond, the ending will be "-yne" for alkyne. If there's more than one double or triple bond, we will have to use the prefix di or tri or tetra to say how many there are. Sometimes you will have to add an A in front of it. For example, if I had a 5-carbon long chain with 2 double bonds, it would be pentadiene, not pentadiene. Very hard to say the pentadiene when the T and the D are next to each other. So we add an A in. Next, we find the main chain. This will be the longest continuous carbon chain, but it must go through the double or triple bond. That means it must go through both carbons of the double or triple bond. If the main chain is cyclical, we will put cyclo in front of that. Next, we want to put in the number where the double or triple bond is located. That is going to get the lowest possible number. If there are multiples, we'll give it the lowest possible total. The next step is to write in the substituent names, and this is the same as we did with the alkanes. The substituent names should be in alphabetical order, and if there are multiples of those substituents, we'll use di, tri, tetra, etc. to say how many there are. And finally, we number those substituents, giving each substituent a number. We're going to continue in the direction that was determined earlier by the double or triple bond. That double or triple bond has priority and determines the direction. We no longer look at the total. And finally, if there are multiples of those, we always put commas between the numbers and hyphens between numbers and letters. So let's start with a small one, compound A. When we look at compound A, we can immediately notice that there's a double bond. That tells us that this is an alkene, which gives us our ending of our name, "-ene", alkene. Next, we look to see how many carbons are in the main chain. This one's very simple because there's only 3 carbons, so we have to go through that double bond, and we get propene. Now, normally we would put in a number in front of this. In this case, in the case of propene, there is no choice. The number will be 1. Because if I put the carbon-carbon double bond on the other position here, we would see that we would still have 1 propene. That means that no matter what, you will get 1 propene, so we just use the name propene. Now let's look at compound B. Again, we see the double bond. That classifies this as an alkene and tells us that the ending is -ene. Next, we want to look for the longest continuous carbon chain that goes through the double bond, and we see that there are 6 carbons, so this is a hexene. Next, we want to put in the number for the double bond. We do that before we add substituents. If we look forward, it would be on carbon number 4, and if we number it backwards, it would be on carbon number 2. Notice that we only put in the number where it starts, because the next number will definitely be the other side of the double bond, because we must go through the double bond. So our answer here is 2-hexene. Next, we add in our substituents. Here we have a side chain with just 1 carbon. That is a methyl group. So we know that this is going to be a methyl 2-hexene. And finally, we're going to number that carbon. So what number do you think it is? Is it 2 or is it 5? Well, the answer is 5 because we need to continue to number in the way that we picked for the double bond. Remember, the double bond gets priority. So that means we have 5-methyl-2-hexene. Okay, letter C. we're going to see that there is a double bond. In fact, there are two double bonds, but still the class is alkene, so we're going to put ene for our ending. There are two of them, so we're going to put diene, and then we want to find out what the longest connected carbon chain is that goes through both of those double bonds. This would be a pentadiene. Remember, place that A in there to make it sound correct. Next, we're going to number those double bonds. Going in the forward direction, we would see that they are on 2 and 4, and in the reverse direction, we see they are on 1 and 3. We choose the smaller one, and so we're going to say that this is a 1, 3 dash pentadiene. Since there are no substituents, we are done with naming that compound. On to compound D. Here we notice again that there is a double bond, so it is an alkene, and our ending will be ene. You can see that there are 5 carbons in the ring, so it's going to be a pentene. Then we notice that it is cyclic, and so it's going to be a cyclopentene. And normally we would put in the number 1 to say where it's located, because that is the lowest number it can have. Remember, in a ring, we give it the lowest number, and it'll always be 1. Since in this case it is always 1, we do not put in the 1, and it becomes just cyclopentene. Now what happens if I had to put a substituent on there? Let's say I had put a fluorine here. We could count this the same way. We would now have the name cyclopentene as our base name. We would put fluoro in front of it, and we'd have to figure out what number to put this in for the double bond. No matter what, that double bond will start with the number 1. So it'll be a fluoro-1-cyclopentene. So now the only question is, which way does the fluorine go? So if I count from the top down, I would get that the fluorine is on carbon number 3. If I count it from the bottom carbon going up, because number 2 has to be the next carbon, that would be number 5. What if I had counted it, counting this carbon as number 1, this bottom left one, as number 1, could I have gone to the next carbon being the fluorine? No, because we must go through the double bond, and the next one must be on the other side of the double bond. So again, this would be 3-fluoro-1-cyclopentene. Now I'm going to add one more in, just to give you a little challenge, one that's a little bit bigger and has more stuff on it. Let's try this one. This is definitely harder than anything you would see on your exam. Okay, so step 1, find the double bond. We see that this is an alkene. Our ending is ene. The next one is the challenging one. We want to find out what is the longest hydrocarbon chain that goes through the double bond. What do you get? Well, you could have chosen 8, 9, or 10. And in this case, we're actually going to choose the 9. Even though it's not the longest, it has to go through the carbon-carbon double bond. So that makes this nonene. The next step is to number the alkene, and if you notice, coming from the top down, that'll give us our lowest number, so this will be a 2-nonene. Then we're going to name those attachments, and you should see that we have a 1-carbon attachment, which is a methyl group. We have 4 chloro groups, and over here we have 4-carbon chain called butyl. So alphabetically, butyl comes first, then chloro, and then methyl. So we have a butyl, some kind of chloro, a methyl, and then 2-nonene. Notice that we have 4 chloros, so we're going to write tetrachloro. And finally, we need to number this. So as we're numbering it, remember that we must prioritize the double bond. So we've already chosen the direction with that carbon being number 2. We'll see that the methyl is also on carbon number 2. Then we see that the butyl group is on carbon number 4, and 2 of the chloros are on number 7, so we'll write 7, 7, and 2 of the chloros are on number 8, so we'll continue on with a 8, 8. And that gives us our whole name, which is 4-butyl-7, 7, 8, 8 dash tetrachloro dash 2 dash methyl dash 2 dash nonene. Now remember, that is all one word, and you can see how sometimes you can have an organic chemical that is actually 700 pages long and still one word. Not surprisingly, the longest name in the American Dictionary is an organic chemical. Now let's see what we do when we have a triple bond. we'll start with naming alkynes. One of the exciting things about alkynes is they are basically the same as an alkene, except where we put ene, we are now going to put yne. So let's start with compound A. First thing, we need to find the functional group. Of course, this one's easy to spot. There's a triple bond, and that means that the ending is yne, yne. Then we find out how many carbons are in the main chain. There's only 2 here, so this is an ethyne. And normally we would put a number in, but we don't need to in this case because the only place it could be is on carbon 1. Now let's do compound B. Here we see the triple bond again, so the ending is yne, yne. And then we count the longest carbon chain from there, and we see there's 3 carbons. This is going to be propyne. If we put the numbers on, we would say it's on number 1. But again, we do not put the numbers on this one because the only position it could be is carbon number 1. You'll notice that if I write the compound the other direction, putting the triple bond on the other carbon, we get exactly the same numbering, number 1. So the answer here is just propyne. Now we can do compound C. Here we see there's a triple bond, so it ends with yne. We see that there are 4 carbons in the main chain, so it is a butyne. And next we need to number that triple bond. In this case, it's going to be on carbon 2. Whether I read it forward or backward, it's on carbon 2. But do I need to put the number in? Yes, I do. In this case, if I put the triple bond 1 carbon over, it would be 1-butyne. So that is a different chemical, and so I do need to have the number. The answer here is 2-butyne. We have one last thing to try, and that is to write the structure from the name. So how do we do that? Basically, it's very similar to the way that we do naming. We're going to start at the end, find out the functional group, work our way forward to the number of carbons, then find our substituents, and then locate them. So let's try 4-isopropyl, 4-methyl, 5-chloro, 2-hexyne. Again, we're going to start at the tail end. We know that there's an alkyne. We'll be placing a triple bond somewhere. Then we're going to look at how many carbons are in the main chain. In this case it says hex, that means 6. I'm going to start by writing those 6 carbons. And this is my main chain. Now I'm going to place my triple bond. And where does it go? Well, you see the number just in front of it, that 2, tells us that we put it on carbon number 2. Now you can pick going forward or backwards. I tend to pick in the forward direction just because it's easier for me to think in the forward direction. Now we're going to add our substituents. We see that we have a isopropyl group, which is 3 carbons joined at the middle. We have a methyl group, which is 1 carbon, and we have a chloro group, a Cl. Let's place those in the right spots. So we know where carbon 2 is, so we're going to go to carbon 4, and we're going to place that isopropyl group. I'm placing it on top. You may place it at the bottom. Doesn't matter which position you put it. In this case, you're going to put 1 carbon, you're going to put the other carbon on one side, and another carbon on the other side, so that it's attached to the middle carbon. Now we're going to put our methyl on. Methyl is also on number 4, so in this case I'm going to draw it downward, 1 carbon. And finally, on carbon number 5, we're going to put a chlorine. That covers all of our substituents. Now we need to add our hydrogens. We need to count each carbon and make sure that it has 4 bonds. So the first carbon should get 3 hydrogens. The second carbon doesn't need any because it's a triple bond and 1 going the other direction. The third carbon also doesn't get any hydrogens. The fourth carbon has 2 groups on it already, so it has 4 bonds already. The fifth carbon has a chloro on one side and 2 carbons, and so it only has space for 1 hydrogen. And finally, the 6th carbon will have space for 3 hydrogens. And we now need to add our hydrogens onto the methyl group, where we get 3 hydrogens, and the isopropyl group. For the isopropyl group, the 2 side parts are each going to get 3 hydrogens, and the one that is attached to that middle one is only going to get 1 hydrogen. And that is your 4-isopropyl, 4-methyl, 5-chloro, 2-hexyne. Notice that it is sometimes hard to draw all the hydrogens in. It gets a little tight. Make sure that it is clear where your hydrogens are attached and that you have the correct number of hydrogens. Let's try one more. In this case, we're going to try 2,4-dibromo, 3-ethyl, 3-heptene. We'll start with the end. We're going to find that we have a double bond because it says "ene," and then we see that there's a hept, which means 7 carbons. We'll draw our 7 carbons out, and then we'll add in our double bond. The double bond is going to go on carbon number 3. And now we need to do our substituents. We're going to see that on carbon 2, we're going to put a bromine. We're going to see on carbon 4, we're going to put a bromine. And then on carbon 3, we're going to put an ethyl group. Ethyl is 2 carbons. We attach it to carbon number 3 here. And the last step is to add in our hydrogens. Carbon 1 gets 3 hydrogens. Carbon 2 gets 1 hydrogen. Carbon 3 gets no hydrogens. Carbon 4 gets no hydrogens. Carbon 5 gets 2. Carbon 6 gets 2. Carbon 7 gets 3. The ethyl group, the first carbon gets 2 hydrogens, and the one hanging off the very end gets 3 hydrogens. And altogether, that is your 2,4-dibromo, 3-ethyl, 3-heptene. And now I have to apologize. When I look back at compound A, I wrote the name incorrectly. I should have alphabetized the substituents, in which case I would have gotten 5-chloro, 4-isopropyl, 4-methyl, 2-hexyne. I do apologize. Make sure that you change it on your paper.